to the idea, he used that pump, he modified this pump, and it worked. We are still using that pump. So almost 80 years have passed, but that pump is the commonest pump being used in cardiac surgery. Next came the idea how to oxygenate the blood. So it's simple, not going into complexity. What he did, he took a steel cylinder and started pouring blood on the corner of it and was rotating the cylinders simultaneously. So with this, the blood spread as a thin film over the surface of the cylinder. And then this whole thing was kept in oxygen-rich environment. So the blood got oxygenated. So we can say it is a vertical cylinder oxygenator. It was very crude, but the idea was that you spread the blood in a thin film and expose it to oxygen. The oxygen will be imbibed in the blood and carbon dioxide will go away. These things were working. He came out, and till 1939 he was able to successfully stop the circulation in cats for about half an hour. He achieved that and he reported that result. But then it was Second World War and he joined Army, US Defense Forces. He was there in the war for 5 years, and 1944 he came back, but he came back because he had some problem in his spine and he was brought back on stretcher. So as soon as he came back to the civilian life, again he just pursues his old passion, that he has to develop the cardiopulmonary bypass system. This same thing was going on, but now the things were changing. He was able to keep the cats alive, but human beings are much larger than cats, so something more needs to be done. Dr. Gibbon had no funds. Till now, whatever he was doing by his own resources. But because of his openness and his good networking, one of his student and fellow, Dr. Michael Clark, who knew Mr. Thomas Watson of IBM, he arranged a meeting between Thomas Watson and Dr. Gibbon. So this was again a crucial meeting for the development of cardiopulmonary bypass. And what happened? Mr. Thomas Watson from IBM, two things helped Dr. Gibbon. One thing, he said that I don't want any benefit out of this project, and at the same time I would insist that IBM should also not get any benefit out of it. It should be purely pro bono. That impressed Mr. Watson a lot. And second thing, lucky for Dr. Gibbon, Watson's own sister had died young with an heart ailment 30 years back. So somewhere it pins Mr. Watson that if he can help, maybe the things would change. So he extended the hand of cooperation. Now Dr. Gibbon had got a great team of IBM engineers and doctors. They worked day and night, came out with models, successive models. This was model 1. With this model, they were able to, they worked on cats and dogs, but when they thought of, you see one thing in this corner, this is the oxygenator, the vertical oxygenator. So this was good enough for cats and small dogs, but when they thought of human being, they thought that at least a cylinder as high as 7th floor building would be required. So they had to change their design. So they came with the idea of this screen oxygenator. Rather than one single chamber, they can have multiple screens on which blood will trickle down, not much of complexities. So they came out with a second model with the change or altered nature of the oxygenating surface. This is model 2. With this, Dr. Gibbon's team was able to keep the dogs alive. Now from cats they moved to dogs, and from dogs they moved to larger dogs. So with this experiment, Dr. Gibbon was now confident. Now we have reached in 1951 that yes, now we are capable of operating upon human beings. 1952, Dr. Gibbon made the first attempt on a 1.5-year-old child, which was diagnosed with a hole in the heart. So Dr. Gibbon operated with the help of this machine and everything, but when he opened it up, he found that the diagnosis was totally wrong. There was no hole in the heart and something else was there. They could not save the child. 6 months after that, again, they operated a person thinking that there was a large clot on the right side of the heart. Again, it turned out that there was no clot and patient's heart per se was failing. So both the patient died. A lot of discouragement. Whole team were discouraged. But still somehow Dr. Gibbon just pursued. In 1953, April, this young girl named Cecilia, they approached Dr. Gibbon. She was diagnosed with a hole in the heart. And she was very much symptomatic. If she would walk a couple of steps, she would become short of breath. So Dr. Gibbon counseled the family. He told, look, this is the scenario. I have operated 2 patients, both have died. And I don't know about the result, though I feel that technically we are able to do it, but outcome I cannot say anything. This girl had the courage to say that I believe in providence. Even now my life is no better than death. You operate, whatever is there, we will take it. So with this consent, Dr. Gibbon had some courage to go on, and then this happened. I think this picture, all of us would recognize. What is this? The man landed on the moon. But exactly, in 53, man didn't land on the moon. It is just a symbolic that what happened on 6th May 1953 was equally important, just like a man landing on the moon. And the team of Dr. Gibbon operated upon Cecilia, and yes, they were able to close the hole in the heart successfully. This was first successful open heart surgery done on 6th May 1953. And this girl survived for 47 years after that, produced 4 children and died happily after that. But Dr. Gibbon never believed in any publicity. So no press conference, no big statement, no publication in big journal. This event died because he wanted to establish that it's not by chance. He wanted to establish that procedure is safe. So he operated on 2 more patients in 1953. Both these patients died. One patient died even before they could connect to the heart-lung machine. Another patient died because of the wrong diagnosis. So these 2 patients died. And this broke Dr. Gibbon totally. Now he gave up. He said, look, this thing is not going to work. He was working on this project for 24 years, and even then, out of 5, only 1 patient could make. So he thought it's too dangerous to recommend to anybody, and he gave up. He gave all his program to his junior, and he said that, okay, I will not do any more such procedures. But the story didn't end here, because this open heart surgery has to go to the mankind. So Dr. Gibbon's friend was Dr. Clarence Dennis in Minneapolis, Minnesota. So he invited him for a talk on all these things which were going on simultaneously. He delivered a talk, and when Dr. Clarence encouraged him or coaxed him to write a small write-up of all his experience, he convinced him that if you write, the people will not reinvent the wheel. Whatever wrong you have done, people will not do. At least that will save others of the trouble. So with that feeling, he just wrote in a half-pager for a local journal in Minneapolis. And he never reported his achievement in any big journal. But what happened? This person, a young doctor, Dr. Kirkland from Mayo Clinic, who happened to read that half-pager, and he was also working on the open heart surgery project. He immediately came to Dr. Gibbon, he discussed, and as Dr. Gibbon he was always open to others that, okay, what I have done, you can take it. So he gave all his experience, project, whatever he has done to Dr. Kirkland. Dr. Kirkland was working at Mayo Clinic, which was the most evolved center at that time in US, with a team of good cardiologists. He evolved, he carefully looked where and what could have gone wrong with Dr. Gibbon. And then in 1955, he reported 10 patients, out of which 9 survived. And that changed whole of the spectrum and scenario of open heart surgery. Within a year, there were 25 centers across the globe which were doing open heart surgery. And now, 30 lakh open heart surgeries are being done globally with backup for another 3 crores procedure in which a heart-lung machine may be required. So you see that what happened on 6th May 1953 is translating into 30 lakh open heart surgery now. And very soon Gibbon got all his dues back. But he had seen that period where all his patients were dying and he was alone. Now, this is heart-lung machine, and this is an essential component of all open heart surgery operation rooms. These are pumps, assembly of pumps. We have 4 or 5 pumps, and this is oxygenator, tubing, which will be going to the patient. It's a complex apparatus, but now it's a routine, and everybody knows how to run it and how to use it. This catheter, this is the historical X-ray picture. They confirm that this whitish streak which we are seeing in that catheter, which on X-ray looks white, has gone from the arm of Frostman into the right side of the heart. So Frostman knew that it is possible to put a catheter or a rubber tubing from the vein to the heart. And this was a great achievement, but not realized at that time. So he left because he came there for a short period, so he had to leave. And then he published his experience in a German journal. He joined another center because now he had to move on. So he joined in cardiology in another center. It so happened that the boss came across that report what Frostman had printed. So what was the reaction? Do you think he applauded him or give credit? It was just opposite. He was fired. He was told not to perform any circus stunts on the patient, and he was fired. Because of this thing, the cardiology career for Frostman ended. There was no cardiology career. So he joined urology and he became a urologist. Then it was Second World War. He joined the German army. He was arrested, was taken as prisoner of war by American forces. At the end of World War II, he was released. And then he settled in a small village in Black Forest, near the borders. In those German-Swiss border, he settled there as an insurance doctor or a village doctor. Meanwhile, his report was noticed by 2 doctors in New York, Dr. Dixon and Dr. Ricard. And they were working on something by which they can take samples of the blood from the heart. This was one way by which they could have done. So they realized the potential of sampling. They can sample at the same time when they put some radio opaque dye through the catheter, they could see the structure of the heart also. So this opened just the potential was enormous. And in 1956, one morning, Dr. Frostman in Black Forest received a call from Stockholm that you are being invited to attend the Nobel Prize distribution ceremony. He was quite confused that what had happened. Why should a village doctor be called in the Nobel Prize distribution ceremony? And it happened so that he was one of the recipients of Nobel Prize of 1956, in just along with Dr. Conrad and Dixon. This is X-ray. I will not run this video. It's a small video. If you inject the dye, you can see the structure of the heart moving. So, in conclusion, these were ordinary people, but they risked their life, they risked their career, and that differentiates them. They were not ordinary people. They looked ordinary, they acted like ordinary people, but their commitment, their risk-taking, and their courage made them much more than an ordinary human being. And because of that only, we have traveled the path from this scenario. If you see this open heart surgery, which were there in cardiac surgery per se in 1950, were just like walking on burning coal. And now this is the scenario where you don't mind doing a cardiac surgery, and you don't have adrenaline secretion when you do a cardiac surgery. And so 1 minute, this clip more to give you an idea what open heart surgery looks like. You see, this is the heart. This we have made a nick and inserting a cannula into the aorta. Aorta is the large artery which takes blood from the heart. This is the vena cava, we say, the tube which brings blood, the venous blood, the dark blood from body to the heart. We are putting another cannula in, we will put a cannula here so that we can remove this unoxygenated or deoxygenated blood, and finally we could direct this deoxygenated blood to the oxygenator and deliver the oxygenated blood through that cannula. So once we have put the patient on cardiopulmonary bypass, you see what in the heart is lying patient, not moving at all. We have incised the heart, we are sucking out all of the blood from the heart, and we can see inside the heart clearly. So when we operate, there is no blood inside the heart, and you can just in next moment you will see. You see, this is the view. This is the view inside the heart with the help of all these things. Absolutely neat and clean. You can see each and everything. This patient's valve was disease which has been removed and had been changed with an artificial valve. So all this was made possible because few people have shown exemplary courage. They have risked their career, they have risked their reputation, and even they risked their life for a larger good. And I salute them for that. Not only those, all those people who have shown courage for the welfare of the society, they deserve my salutation. Thank you. Thank you.
It was a wonderful lecture. I'm sure we learned not only about the heart, but about the bravery and courage. I request the audience, if you have any questions, you can stand up and ask questions. And may I request Professor Shiv Choudhary to come here to the stage and answer the questions. Right. Please be brief, and anyone can stand up and ask your question.
Very simple question, sir. We come to know about some patient who have been operated for a heart problem, and doctor report that it was successful operation, but after few days they died. What could be the possible reason for that?
There may be n number of causes. Surgery takes care of one part of your ailment, because there are 2-3 things to be understood. One thing, surgery is not always curative. Certain surgeries are only palliative, to decrease the symptoms or to prolong the life. So one cause of that is residual disease. Secondly, the disease correction, you may be correcting one aspect of the disease. For example, if the pump is weak and the valve is not functioning, when you operate, you take care of the valve. You are not able to do anything for the pump. So maybe the pump problems overtake and patient dies. Third thing, for example, this patient who dies suddenly may be having some rhythm problem. So heart is not a simple organ. There are multiple mechanisms, multiple systems working in parallel. So the doctor may have operated on the one system, the other system may be a problem. Yes, please.
I have two parts of the question. The first part is like you were showing the surgery part. So how do you revive back the heart after you have already operated? And secondly, you had shown the instrument or the equipment which you are using when you're doing the open heart surgery of 1950s. So what has is there any new development on that side in terms of technology
Okay.
of smaller
So first part of your question. First thing, we have to stop the heart. So when we cardiopulmonary bypass is one component, but to stop the activity of the heart, we infuse potassium-rich solution in the heart. So all the electrical and mechanical activity of the heart goes away. Once we have done everything, we start perfusing the heart with the normal blood, circulating blood. Whatever is circulating to whole of the body, we start circulating. So the potassium will be washed away, the heart will start beating. Second part of your question, what improvement has taken place? Basically, concept-wise, there is no improvement since 1953-54. Only thing is that the materials have changed. For example, oxygenation part, the previous oxygenators were not very efficient in matter of gas exchange. Now we have got better oxygenators. So material have changed, the size have become smaller, the things have become disposable, and they have become more user-friendly. In time of Gibbon, for each surgery, he has to dismantle, clean and sterilize 450 components of heart-lung machine. Now everything comes in a sterilized pack, you just take it, put in the holder and start working. So those are changes. Yeah.
Does it make a difference if heart is on the left side of the body or on the right side of the body?
No. It doesn't make any difference, provided there is no other associated malformation. Usually when the heart is on the right side, there may be associated malformation. But if there is no other associated malformation, then position of the heart doesn't change its function and efficacy. Yeah.
I'm from social sciences background. I'm layman in this area, but I have some idea about this. Why heart pumps on its own? It's because of electrical impulses generated by chemical balances, or it is something supernatural power, gravitational powers, or something else. Why heart pumps on its own?
For the medical people, they have not able to accept the idea of supernatural. Yes, we all believe that it's a part of some grand design which we are not able to decipher. But for easy explanation, the heart, there are two parts. One part is generating the generation of the rhythm. That means at each time interval, heart should start contracting. Another part is contraction itself. So timing and the force of contraction, both can be explained in terms of biomechanical process. Yes, please.
Vanderpool oscillator, jump for that. Nonlinear oscillator, Vanderpool oscillator.
No, I didn't get the question.
You're saying something about oscillator.
Why is it called oscillator?
Oh, why is it called an oscillator?
No, oscillator, there is oxygenator. It is oxygenator. Oxygen means it adds oxygen to the blood. Oscillator, maybe my throat is so husky, so you heard it oscillator. No, it's oxygenator. We add oxygen to the blood.
I was talking about rhythmicity.
Yeah, rhythmicity is an oxygen. You can say it is an oscillator because it keeps on beating at a regular interval. Some cells of the human heart, they have got
anything which has a rhythm and periodicity is an oscillator.
Yeah, please.
We nowadays in the cell phone use that often we are advised not to keep it close to the heart. It may affect your cardiac system. So how why?
For current understanding, people with normal heart, nothing is going to happen. But for people who have got pacemaker inserted in the heart, near the pacemaker is put here. So they should avoid putting their cell phone near the pacemaker channel, because that may interfere with their pacemaker.
Other people should not know.
But best would be not to keep, because it is uncharted thing, I would say. We don't know how the things work. After all, it's a radiation. Our understanding is based on current knowledge. Maybe after 20 years, 30 years, we come out with something that it was harmful. So if you can avoid, avoid.
Just a small extension of the previous question. So is there a time duration in which the heart should be revived, or is it like
No,
suppose
with the current techniques, we are able to stop the heart for 4 hours, 5 hours. That is safe.
that is safe? So
Up to
beyond
4-5 hours, it's safe.
beyond that, it is.
Because if we keep on going, we stop the heart by depriving it from blood. Once the blood is deprived, all the nutrition is also deprived. So if we walk against nature in any part of the life, it is harmful. So 4-5 hours, good enough, because for transplant purpose, we take out heart from in another city, then we transport in 4-5 hours, it's okay.
Physicians see heart attacks due to the physical defects
Yeah.
like cholesterol or pump failure or so many other causes. They see the physical aspect. But philosophically, sometimes I get an idea when the earth rotates on its own, when there is a physical dislocation between the body and then earth movement, sometimes people get heart attack.
Maybe, why not? All these thoughts may appear new. For example, when Galileo said that the earth rotates around the sun, it was a new idea, but subsequently it got proved correct. So what you are talking may prove correct in the future. But our understanding is a little bit limited. We are still infants trying to learn about the so many facts which Almighty has produced.
Thank you.
Although we know that nature has given like a eye to eyes, two kidneys, two lungs, but is there any specific reason that why nature has given you only one heart? Even in the heart, you have the four balls. So, but heart is an important part of our body.
Look, what has happened, if you see the evolution of the heart from lower species to higher species, from reptiles to mammalians, in reptiles the heart chambers are in series, only 2 chambers are there, because there is no partition between the oxygenated and deoxygenated blood. As the species evolved from reptiles to mammalians, there is a clear-cut separation between oxygenated and deoxygenated. So we have got 2 hearts, right side heart and left side heart, two circulation systems which are running in series. So factually we have got 2 hearts, but they have been joined together, and let me just say something. God has given only 1 heart to human beings, so they remain fidel to their partners.
Apart from the fact that his lecture was really outstanding, there are 2 takeaways for me from this lecture. One is that cardiologists cannot survive without engineers. The other lesson for me is that economists cannot survive without cardiologists. Because if people die at very young age because of heart failures, and people who are productive are leaving this earth, economists cannot survive, right? So it is very apt that we have invited a great cardiologist for this lecture by an economist, Professor Pradeep Choudhary. So let us give Professor Shiv Choudhary a big hand.